And so when we're talking about enterprise databases, we are talking about essentially two types of databases, operational databases and data warehouses. Operational databases are used in operations such as recording accounting transactions. Data warehouses are huge storehouses of data, often used with data mining to extract business intelligence, which you recall we talked about in Chapter 1. The major modules include accounting, human resources, perhaps accounts receivable, perhaps accounts payable, payroll, and other items or examples like that. And they can both use the operational databases and the data warehouses. External databases are obviously external to the organization. Often the external databases are accessed with a browser over the internet. For example, Gartner Research stores its IT research in a searchable database. For a fee, companies can purchase the rights to access this database and use for IT research. The database administrator, or DBA, has specialized database skills. Because databases have become so crucial to organizations' operations and performance, the DBA is a highly valued IT staff member. And so, although simplistic, it is very important insight to use when designing and entering data into a database. So we essentially want to enter data once, and there are several reasons for that. One is cost. The organization has to pay someone to enter data, and the more times data has to be entered, the more this costs an organization. And then there's also this idea of accuracy. Each time the data is re-entered, there's another opportunity for an error to occur. So two advantages are of entering data only once is cost savings and then level of accuracy. The key is to design the database in database forms so that the data is entered only once and then used in the various locations where needed. When you're creating a customer invoice, you don't need to re-enter the customer's address each time you create an invoice. Instead, you enter the customer's address in the customer record, and then when creating the invoice, the customer's address is automatically completed. So you can see the importance of this of entering the data once. It reduces increases accuracy because you don't have the opportunity for it to be miskeyed the next time, and it reduces cost. And so we want to, as we design the systems, to make sure that we minimize the number of times the same piece of data is input as much as possible. And so with respect to the 80-20 rule, if a database is well designed, then the maintenance will be very streamlined. If a database is not well designed, then maintenance may become very time consuming. In addition, the database may not function properly or data may not be able to be retrieved. So again, we want to say we spend 80% on the design of the system and 20% on the maintenance. And so the accounting software is what you see on your computer screen. Behind the computer screen is the database management system, which is a piece of software that works with the database. And so the accounting database is also behind the screen. When the accounting professional enters information into the accounting software, such as the information about paying bills, then the information is passed to the database management system and then stored in the accounting database. If the accounting professional is required to unravel errors in the accounting system, knowledge of how the accounting database stores and retrieves data becomes important. And what we'll see as you continue to explore this is that there are pieces of information that are entered, and if we say we want to enter data once, so it's entered, then something is processed. Some accounting processing happens to it. This creates another piece of data that is then also stored in the database. And so some other process may happen to that, which creates another piece of data in the database. But each one of these is a different piece of data than the one piece previously because of this processing. And so the issue becomes one of knowing, well, what are the processes applied to the data, and for my informational needs, which piece of that data, after which process, do I need to retrieve that information? So we can see that it may become important as we continue to grow in this area of understanding, well, so where are all the pieces of data in the database, and what are the processes that have been applied to that data to make it different from the other? And so in the IT architecture for an accounting system, there are three tiers. the user tier that appears on the user's computer screen, and that's often associated with the database forms and reports for inputting and outputting data. The application tier, which consists of the software application, and in our case it's the accounting software, and then there's the database tier that consists of the database used in the accounting system and the DBMS software. And so again, we get back to these database essentials, and what we see in this diagram is how the 4 database essentials build. And we talked about this earlier also, but you recall that a field is a piece of data, perhaps like a zip code. The record is a collection of related records or fields. So all of the records relate to one customer would form a customer record. The database table is a collection of related records. All the customer records form together a customer database table. And then the database, again, we said, was a collection of related tables. So all the tables needed for an accounting system might form an accounting database. So a few more database essentials are that database forms are used to input data, such as the customer invoices or checks. So we can input data into a database if we access the table. And again, if you're familiar with Microsoft Access, it's easy to see how you enter data directly into a table. We prefer to use database forms because we can build certain controls in those that we'll talk about later. But the forms help the user for ease of entry, and it may validate some of the data at the same time. Database queries are used to search and extract data from the database. For example, if you wanted to know all the purchase orders that a particular customer made in the past year, a query could extract that information from the database. So a query goes out and it pulls data for us. The report is used to present output of database queries. So an example of a database report would be an annual income statement. So we can get data out of the database either through queries or reports. To illustrate how to build a database, we'll cover the abbreviated steps for building an Access database for Espresso Coffee Company. And here we see the abbreviated steps for doing that. So we identify and build database tables, we identify and enter the fields, we select the primary key for each table, and then we identify and build relationships among database tables. So the first step is to identify and build the database tables. When identifying database tables, we know the database tables can consist of people such as customers, things such as inventory, and transactions such as sales transactions. And here we see those transactions, those cycles as they impact people reflected in this diagram. So we review the baseline accounting system as a good start to understand what we have out of the box and perhaps some configuration or setup concerns, and move forward from the baseline system. And so after identifying these people, things, and transactions, we identify the corresponding database tables that will be needed. For example, information about customers will be stored in a customer database table. Information about inventories might be stored in an inventory database table, etc. So step 2 is to identify the fields needed for each database table and then enter these fields into the database table. For example, here you can see that the fields used in the customer database tables. So for the customer, you can see we've chosen the field's customer number, which becomes the primary key, and so we see the small key beside it, and this is in Microsoft Access. We see the customer name, their last name, first name, street address, city, and so on. The primary key connects the customer table to the sales order table, and in the sales order table you can see the fields are sales order number, order date, sales order shipping, and so on, with the sales order number being the primary key. That primary key connects the sales order to the item table, and you can see there we have the item number, which is the primary key, the item name, and item description. So then we have to move on to entering this data, or entering these fields of data into the database table. Each table must have a primary key as a unique identifier for each record. For example, the customer table will use the customer number, as we just saw, as a unique identifier. So this means that each customer must have a different customer number. No two customers should have the same customer number, by definition as a unique identifier or primary key. The sales order number will be the sales order number. Or, I'm sorry, the sales order table will use a sales order number. And then the item table will use the item number. And so there again, you can see none of these primary key data fields should be the same as, have the same value as any other primary key data field in each of their respective tables. And so then step 4 is to identify and build the relationships between tables. In a relational database, the tables are connected or related. And there are 3 different types of database table relationships: a one-to-one, a one-to-many, and a many-to-many. And so in a one-to-one relationship, for each one record in one table, there is one record in another table. And so here we see that for each one record in the employee table, and that record consists of the employee number, their name, first and last, their street address, city, state, zip, etc. There is another record in the 401k retirement account information table that provides information about that employee, and they are connected through the primary key employee number. So there's one-to-one relationship between the employee table and the 401k retirement account information table. There may also be a one-to-many relationship, and so here we see that for one record in one database, there are many records in the related table. And as an example here, then we see a customer table, and we see that there is a sales order table, and we can see that, well, there may be multiple sales order tables where the primary key in the sales order table is the sales order number for this customer number. And so a customer could have 5 different sales orders opened up with us or in existence with us at any point in time. And so we have a one-to-many. There are many sales order records that could exist for one customer number. And if we think about that, so the question becomes, what is the maximum number of orders a customer can place? And the answer to that becomes many, right? So a customer could place many orders with us, but it would be many orders associated to one customer. And that's why we have this idea of one-to-many. If we compare that with this idea of one-to-one, what is the maximum number of customers who can place a specific order? And that's really only one, right? We can only have one customer replace one specific order. And so that becomes a one-to-one. And then we have this idea of many-to-many. And so that exists where there may be many records in one table that relate to many records in the related table, right? So one sales order can contain many items, right? So, and a specific item can appear on many orders. So we have this many-to-many relationship. Many-to-many relationships are problematic in databases, and so we have to remove these many-to-many relationships, and we do this through the use of an intersection table where we essentially establish a one-to-many relationship instead of a many-to-many relationship. And so when we talk about database anomaly, there are 3 types of problems in database tables. One is the deletion problem, where we're deleting one record, such as a customer, and that causes the deletion of other records. We have an update problem, where updating one record requires updating multiple fields. And then we have this idea of an insertion problem, where we insert a new field into the table. And so we have to resolve these database anomalies so that we don't get error messages or bad data coming out of our database. And we see here then that a well-designed database is free of these deletion, update, and insertion anomalies. And we get to this anomaly-free state through a process called normalization or database design modeling. And so in introductory accounting courses, manual accounting systems are often used to learn accounting systems. And I'm sure you all have done this if you take in some of your introductory classes where you talk about T accounts and accounting debits and credits and journal entries and how these are created as a result of the analysis of certain transactions. And you recall we talked about this back early on when we looked at the accounting cycle. So what this table does is summarize the major differences between a manual accounting system and a database accounting system. The database accounting system obviously saves more time because some steps are completed automatically, such as posting two accounts. And we rarely ever see manual accounting systems anymore. Worst cases, what we see anymore are accounting systems that are maintained on Excel spreadsheets. So that's the new day definition of a manual accounting system.